Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zidan Shabani, and today on this video, I'll be explaining a little bit about redundant rod reflector. And this material is the uh, further material from the previous video about rod reflector. And now I'm going to discuss and to do some configuration using Pinet Lab about what is redundant rod reflector and how does it work. So I made some points here. In previous video, I was talking about IBGP. So IBGP requires full mesh topology because there is a method called split horizon rule. It takes part of for preventing routing loop in IBGP network. So like I mentioned on the previous video, when we applying IBGP, we must be implemented full mesh topology to prevent routing loop or to make in order to make it function correctly. But what if we don't use full mesh topology? We can still solve that problem using a method called rod reflector. So we can implement rod reflector in non-full mesh IBGP network, and with using this method or rod reflector, it means we violate the split horizon rule when each router in IBGP network still re-advertise the updates about new road information, but we still can prevent routing loop because in road reflector it uses two BGP attributes. First is originator ID and the other one is cluster list in order to prevent routing loop. So what are originator ID and cluster list? So first, originator ID is actually a router ID from road reflector client router, and the originator ID is only present in BGP updates sent by road reflector router. And the other one is about cluster ID and cluster list. So cluster in the terminology of IBGP is a grouping of road reflectors and their clients. And by default, each single router reflector along with its client, along with its road reflector clients constitute a single cluster. And cluster ID is actually a router ID from root reflector, and it can be redefined manually. And cluster list contains the cluster IDs of all the clusters that have processed a particular route. So in a cluster list, it can contain multiple cluster ID from any route reflector routers that have processed a particular route. Okay, that's all. Some little explanation about originator ID, cluster ID, and cluster list. What do I explain it in the beginning? Because these two attributes are the attribute that I will highlight in this video, in this configuration. So let's jump to the configuration video using Pinet Lab. Alright, so here I'm already logged into my Pinet Lab, and here I have the almost same topology like the previous video, but now in this topology, as you can see, there are RR1 and RR2. So RR stands for road reflector. So this router 2 and router 3, I will use it as road reflector. So redundant road reflector, it can mean we have multiple road reflector within an AS. So our AS 1945 for this video. So I have four routers here, and two of them are root reflector, and two of them and R1 and R4 are the root reflectors clients. Okay, first let's jump to the R1 first. Okay, I have already configured some basic configuration, including hostname and IP addressing. So the addressing is like this. I have configured the loopback interface for each router. For R1, the loopback interface is 1.1.1.1, and I also have configured the IP address for each active interface. And this is the loopback interface for R2, this is for R3, and this one for R4. I hope you're not confused about it. Okay, let's open the terminal again. Here I'm still on R1. Okay, let's reconnect the others. Enable. And first let's check the information about IP address and active interface. Show IP interface brief. As you can see, there are a lot of interface here, but just ignore the others. We only focus on these two interface. First, Ethernet 00 with the IP address 11.11.11.1, and the other one is loopback interface 1.1.1.1. As well as the other router, I also have configured almost the same thing. Show IP interface brief. For R2, it has three addresses. First, Ethernet 00, and second for Ethernet 01, and the third for loopback 0. Okay, you can see here about the addressing information. So first I will configure the IGP routing protocol. In this video I'll be using RIP or routing information protocol as our IGP routing protocol before configuring the IBGP, because like I explained on the previous video, both BGP, in this case IBGP, it can only run or operate uh, with the IGP configuration before. So we need to configure the IGP routing protocol first before configuring IBGP routing protocol. So let's go to configure global configuration mode. Here I'm on R1, as you can see. Router brief. I'm gonna use version 2. First network is network 11, and then network 1.1, auto summary. Okay, I'll do the same thing for the others router. Configure terminal, router read version 2, network 11.0.0, network 22.0.0, summary. Computer terminal, router read version 2, network version 20.0.0, network 33.0.0, and network 3.0.0. I'm sorry. Now to summary, and the last one for R4. Computer terminal, network 23.0.0, auto summary version 2. After we configure the IGP routing protocol, now we can continue configuring to our BGP or IBGP routing protocol. Router BGP and our IS number is 1945. Okay, before continuing the configuration, I will explain that on this configuration, we only have to configure the R1 to pair with the route reflector, which are with R2 and R3, as well as R4. I will configure it to only pair with R3 and R2. But for the route reflector for R2 and R3, I need to pair it with all of the clients for R1, R3 and R4, as well as R3. I will configure it to have a pairing with R4, R2 and R1. Okay, so now I'm still in R1. So the first network is the router 2. Mode IS is 1945. It's the same because this is IBGP configuration. Don't forget to update source from loopback 0. And the other one is pairing to R3. Update source loopback 0. Cannot from R2 because this is the route reflector. We need to pair it more than R1. So BGP 1945 equal first R1 1945 make source loopback 0, and don't forget to make it as route reflector clients. R1 is our route reflector client. Now pairing to R2. Oh, I'm sorry. I mean pairing to R3 because here I'm on R2. Update source loopback 0. Route reflector client. Then to R4. Source loopback 0. Route reflector client. Okay, the pairing our BGP configuration is almost the same in router 3 because this is also the BGP route reflector. 1945 refers to R1. 1945 source take 0 with reflector client. Next to R2 update source loopback 0 reflector client, and last to R4 update source loopback 0 reflector client. Okay, the last one for the R4 for BGP 1945 neighbor first to the R2 as the first route reflector router remote AS 1945 sorry the source loopback 0 and last one with R3 update source loopback 0. Okay, now I'm going to see the information about our IBGP configuration. You can type this command do show IP BGP summary, and the IBGP routing table is has been formed. The neighbor 2 and 3, router 2 and router 3. To show IP BGP summary, and it has 3 neighbors, router 1, router 3 and router 4 from R2. And it also has 3 neighbors, router 1, router 2 and router 4. And router 4 will have only 2 neighbors like R1. Okay, I can still ping R4 from R1. It means the route reflector is been configured successfully. Okay, let's back to our topology first. Like I said before in this video is talking about redundant route reflector and how route reflector methods can still work without using split horizon rule to prevent routing loop. Like I said before, there are two additional attributes from BGP attributes. There are originator ID and cluster ID or cluster list. So those two attributes are used in route reflector context in order to prevent routing loop without using split horizon rule. So the let's see To make it easier, I'm going to add another network from R1 and from R4. Okay, let's go to the terminal. I'm going to add one additional loopback interface as the new network from R1 and R4. Loopback interface 1. In IP address, for example, I'm going to make it 10.10.10.10. And from R4, I'm going to do the same thing. Let's loopback 1. The address, for example, 40.40.40.40. And afterward, I'm going to advertise the new network from R1 and R4 to the BGP. Go to router BGP 1940 configuration, and we can advertise the new route from R1. Network 40.40.40 with subnet mask call 255. Okay, now let's see the BGP information about the new network from R1 point of view. So this I'm going to check the route information from R1 to the new network of R4. You can type this command, so IP BGP with the uh, IP address, with specific IP address, and hit enter. As you can see, to reach the 40.40.40.40 network from R1, we have two paths here. You can see here paths to available, and it still chooses the only one best path. And here the originator, as you can see, like I mentioned before about originator ID. Originator ID is 4.4.4.4 because this is the network from R4, and when R4 advertise or sends the BGP update to the router reflector, it will include its originator ID, which is R4's router ID 4.4.4, and you can see cluster list here 2.2.2. It means this message is received by R1 from 2.2.2.2, which is from the R2, and the other one path is received from R3 as reflector client or reflector as well, with the same originator ID information, but with different cluster list information. This is 3.3.3.3, and it is the uh, router IDs of R3. And there is best information here. That means the R1 will take the path from R2 that directly connected to reach the network 40.40.40.40 from R4. As you can see, because there are two paths towards the same destination, it can make the resource of the router will be exhausted. So the router will work more than usual because we have to same paths towards the same destination. I think we have to paths towards only one destination. And let's see the information from R2 as well to show IP BGP 40.40.40.40, and R2 it also received two paths information to reach the 40.40.40.40 network. The first one is from route reflector R3, and the other one is directly from the route reflector client from the R4, and the router 2 chooses the best path is the paths that originated from the router 4, because router 4 is also the router 2 client. And if we see the information from router 3, do so IP BGP 40.40.40.40. As you can see, Archer it also has two paths towards the 40.40.40.40 network, and the best part is directly from its client from R4, but it still has the path information from R2. I think it's all about the router resources. Why do we need two paths in to reach the same destination? And what about we see the route information from R4 itself to show IP BGP 40.40.40.40. You can see the output is different from R4. Uh, it looks like R4 doesn't receive any updates or information from R3, but actually it does. R4 still receives an information about its own network from R3 uh, because the split horizon doesn't operate here, so R3 will also re-advertise the updates to R4, even though the R4 is the original or the origin from the updates. I'm sorry. But we saw before, on the output from R4, the output is different from R1, R2, and R3. But it doesn't mean R4 doesn't receive any message from R3 as its route reflector. To see the more detailed information, we can use this command to debug IP BGP IP version 4. Okay, enter. And now I'm going to clear the BGP peering from R1 to R3 just to see the message and what's going happen if we uh, clear the peering from R4 and R3. Okay, I'm going to clear the session from R4 to R3. Clear IP BGP 3.3.3.3. Okay, now we have received a lot of messages here. but we only focus to this message. You can see BGP receive update about 40.40.40.40/32 denied due to next hop is our own address or originator is us. So this is from R4. You can see here R4. After I cleared the BGP session with 3.3.3, which is with the route reflector, these messages appear here, and from this message we can learn that R3 still advertise the network about 40.40.40.40. And like I mentioned before, when the root reflector sends BGP update, it also includes the information about originator ID. And the originator ID about this update was about 40.40.40.40 network. The originator is 4.4.4.4. It means this R4's router ID. So when R4 receives that information, that update information, it will see the originator ID. When the R4 sees the originator is same like itself, it will deny or ignore the packet. So uh, that's how it works, or how route reflectors still work to prevent a routing loop by using originator ID information. It will be like this. So without using split horizon rule, we can still prevent the routing loop in IBGP network with no full mesh topology. With route reflector and route reflector uses two BGP attributes, which are originator ID and cluster list, to prevent routing loop. Now after discussing about originator ID, the next attribute that used here is cluster ID and cluster list. So let's back to the R1 first. Show IP BGP 40.40.40. Like you saw before, the paths are two here to reach the same network from R1, and the cluster list is still different. First is from 2.2.2 and the second one is 3.3.3. Now I'm going to set or to reconfigure the cluster ID from R1 and R2. So these two route reflector routers will be on the same cluster. So these two routers will have the same cluster ID in order to make the research is more lightweight than before. So R1 will have only one path towards this network. Okay, to do this, I need to move to R2 first, and let's move to router BGP 1945 configuration, and we can redefine the cluster ID by using this command BGP cluster ID. And for the cluster ID, I will use this network, maybe 22.22.22.22, and hit enter. And I need to do the same thing from the other one router route reflector, which is R3, router BGP 1945, and BGP cluster ID 22.22.22.22, and hit enter. Okay, now let's see the information about BGP network 240.40.40 again from R1. You can see it still has two paths towards this network, but you can see the cluster list now is different. The cluster list is different. Now it's 22.22.22.22, but it still has the two paths to reach this network. Okay, now let's check the information from R2. I do show IP BGP 40.40.40.40, and there is a difference from the output from R2. Now R2 only has one path towards or to reach the 40 network. The path is directly from the route reflector client or from R4. And to see the how cluster ID works in route reflector, we can do almost the same thing like we did from R4. Okay, first we can activate the debug command, debug IP BGP IP version 4. Unicast updates in. Okay, after activating the debug, I'm going to clear the BGP session from R2 to R3, and it sorry, clear IP BGP, and now we see the almost the same messages like we saw on R4. Now let's take a look for these messages, and here you can see the same messages about denied, about something denied. So when we clear the session of IBGP from R2 to R3, because those two are our route reflectors router in this topology. When R2 receives the BGP updates again from R3, you can see BGP 3.3.3, it means it receives, or R2 receives the information BGP update from 3.3.3, which is from R3, update about 10.10.10.10 network, and the message is denied because it's reflected from the same cluster. So the router 2 as the route reflector, when it receives the BGP updates message, it will see the information about cluster ID, because we have changed the cluster ID from R2 and R3 to the same cluster ID. That's why R2 will drop or will ignore the packets comes from R3 that includes the information about cluster ID, because R2 says the cluster ID is the same, so it will ignore the packets. So it also will help to prevent routing loop on IBGP network. And now I'm going to try what's going to happen if I shut down the BGP peering from R2 to R4, and I will see the effect from R1. And to do it, go to router BGP again, router BGP 1945, neighbor 4.4.4. I'm going to shut down this peering and hit enter. Okay, now let's see the effect from the configuration for R1. I'm going to see the output from the same command, show appgp for the .40.40.40 network. And now we only have one path to reach 40.40.40 network from R1, and the originator is still R1, R4's router ID, and parcel list is 22.22.22.22, and R1 receives the information or about this route is from 3.3.3.3. It means R1 receives this update from R3 because we have shut it down the peering from R2 to R4. So R1 still can reach the R4's network without using uh, multiple paths to reach the same destination, but now it only has a single path to reach the 40.40.40 network, and it's from the R3. So if I ping this IP address again, it's still I can still receive it. But from R4 I can still ping the router one's IP address. Now R4 is also only have one path to reach the router one's network, and it's from router 3 as reflector router because the peering from R4 and R2 has been shutting down before. Okay, maybe that's all for today. So like I said before in this video, I just want to highlight something about originator ID and master ID when there are multiple route reflectors within an AS. Okay, I hope it can be useful and easy to understand. Thanks for watching. Wassalamualaikum warahmatullahi wabarakatuh.